Alright, in this video we're going to talk about Unit 5, Objective 4, the limit definition of a derivative. So we know what a derivative is. We know it's the slope of the tangent line to the function at any given point. So what we're going to do is use the idea of a limit to actually show why that derivative is that slope of the tangent line. So the definition of a derivative using limits is this thing right here in red. And you don't have to write this down because it's on your notes paper. But what it says is the derivative is going to be equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And where that's coming from is the slope of a line that you learned back in Algebra 1. So if you think about the slope of the line from Algebra 1, that was y2 minus y1 over x2 minus x1. So where this is coming from with the x plus h and all of that stuff is we have some value x right here. And that's going to have its f of x value, its y value right here. And that's going to give us some point p. So what we can do is we can create another point that's going to be not just x away from the origin, but it's going to have an x value of x plus h. So it's the distance on the x value, on the x-axis between our first point x and our second point x plus h is going to be a value of h. So that point's going to give us q right there. So we have an x value of x plus h, a y value of f of x plus h. Then on p we have an x value of x and a y value of f of x. So if we think about our slope formula from a long time ago, y2 minus y1. So that would be f of x plus h is y2. F of x is y1. So we have f of x plus h minus f of x. Then we have x2 minus x1. Well, x2 is x plus h minus x. Well, x plus h minus x is going to give us just x. So this right here is our slope formula from Algebra 1. So how we get this derivative, what we're going to be trying to get to is the slope of the tangent line. So we have the tangent line at P right here. We're going to try to make this secant line from P to Q a tangent line. So the secant line is going to be having the slope between P and Q, so our slopes are represented with this. Now how we're going to do this is this limit as h goes to 0. So this distance between x and x plus h, remember, is just h. Well, if we make h go to 0, that distance between the 2 points go to 0, you can see that our secant line, the green one, turns into a tangent line. So we start out here with some value h in between our 2 points, and we're going to make those points so close together that they're actually going to be sitting right on top of each other. And that's going to give us the slope of the tangent line at a point. So that's where our definition of a derivative comes from. So if we look at the notes paper, there's actually two different limit definitions of a derivative. One's going to be the derivative as a function. So we're going to get answers like 3x squared plus 2x plus 1 if we use this definition. And the other one's the derivative at a point. So we're going to get answers like 7. And the way to tell the difference between the two is to look at what your limit's going to. If your limit's going to h, then we know our limit's going h goes to 0, then we know we're going to get the derivative as a function. If our limit is x goes to some point, then we're going to get the slope at a point. Now, there's two ways we can handle these types of problems. So here's the first question that we have, the first example. The limit as h approaches 0 of the quantity x plus 3, or h to the third minus x to the third over h. And this is as h goes to 0. So the first way we can do this is to recognize this as a derivative problem. If we look back at our limit definition, we have f of x plus h minus f of x all over h as h goes to 0 is equal to f prime of x. So if we're looking at this problem again, this is really asking us for f prime of x. We just need to know, well, what is f of x? And we know it's looking for f prime of x because we have x plus h minus x as h goes to 0, all over h. So this looks like the first limit definition. So if we think about this, our limit definition says the limit as h approaches 0 of f of x plus h, make that a plus sign, minus f of x all over h. Well, this looks like x plus h to the third, and this is just x to the third, so it looks like f of x is really just x to the third. And we can see that because this says f of x, which makes this f of x. And to check it, if we did f of x plus h, that means take x plus h, put it in where we see an x, we'd get x plus h to the third, and we have that right here. So what we can do now that we know f of x, and we know this is looking for f prime of x, we just take the derivative. F prime of x is equal to 3x squared, and we're finished. Now, if you don't recognize that, there's another way to do the problem. Well, there's a couple of ways, but there's a shorter way to do the problem. So if we reset and go back to here, if we look at this problem, h is my variable, not x. And we know h is the variable because it says h approaches 0. So h is the variable. X is a constant. So plug 0 in for h, we get x plus 0 is x to the third, minus x to the third is 0, over 0. It's an indeterminate form. We can use L'Hopital's rule. We have to be careful, though, because h is our variable. So if we treat h as the variable, L'Hopital's rule says take the derivative of the top, the derivative of the bottom. So we get chain rule here, 3 times x plus h squared times the derivative of the inside is just going to be 1, minus 0, because remember, this is a constant, h is the variable, divided by 1, and then take the limit again. Plug 0 in for h, x plus 0 is x squared times 3 minus 0 divided by 1 is 3x squared. So the other type of limit definition, the one at a point, would be something like this. So if we recognize it, our definition says as x approaches c of f of x minus f of c over x minus c. So the way to kind of look for this one is if x goes to 3 and we have an x minus 3 in the bottom, this is probably the derivative at a point. Again, the quick way is, well, I recognize it's a derivative. This is telling me I'm looking for f prime of 3, and we know it's 3 because of this value here. What is f of x? If we can find f of x, then we can take the derivative real quick. Well, according to our definition, f of x is what comes first. So f of x is going to be the square root of x. To double check it, f of 3 should be this part here, which would be the square root of 3. So that checks out. We know that that's f of x. So f prime of x is going to be equal to 1/2 x to the negative 1/2 power. We want to plug 3 in, right? We want f prime of 3. And we're going to get 1/2 times 3 to the negative 1/2 power, which could be 1 over 2 radical 3. And if you would rather use L'Hopital's rule, we can use L'Hopital's rule as well. So x is going to be our variable this time because that's what our limit says. So if we plug 3 in, square root of 3 minus square root of 3 is 0. 3 minus 3 is 0, so we can use our L'Hopital's rule. And if we take the derivative of the top, we're going to get 1/2 x to the negative 1/2 minus 0 over 1 minus 0. Take the limit as x approaches 3, so plug 3 in, and we're going to get 1/2 3 to the negative 1/2, which is going to be 1 over 2 radical 3. So if they're asking for you to take these limits, you can get by with L'Hopital's rule, but there are some times when you have to recognize that it's a derivative, and we'll see a couple of questions like that in class. But for now, that'll do it for this video, and we'll see you in the next one.